To help us in identifying a translation of the given line here by a vector identified as -1 and -3, I have already presented here the graph of the given line using the intercepts. So if you are not yet convinced with this, you can always try to graph it on your own or look at the first video pertaining on translation of a line in this same playlist, because you would see there the process. Now this time, we are going to predict the precision of the translation here, but of course we can look at the possibility of it being related to the vector, because direction vector, if we're going to look at that as a vector as alone, if we're going to have the point of reference as the origin, it's actually somewhere here. You have -1 and -3, something like that. So probably our graph is being pushed into that direction, or since it's -1 and -3, in that direction, it's being pushed down. Okay, so later on we will see if our graph will be really pushed down. Now, take note and don't forget that the translation of a line is related to the translation of a point. For any point, in this case, for our points described as x and y, so for any point in our L, x and y, okay, we are going to translate that. Okay, let's just say any point, right? So any p by the vector, we're just going to use this process, add the first components by the first component of your vector. Take it, our vector earlier was -1 and -3, and then for the second component, also the second component of your vector. That's how we translate every point. And since a line, specifically for our given line here, L, which is 3x minus 4y is equal to 12. This line consists of infinitely many points. We're going to do the same for every point therein. By the way, let us not forget, since our identified point is x and y, so the first and second components will be x and y now. Okay, so we will be looking for the translation of this, let's say L prime, which would contain x prime and y prime. But this case, take note that all x components would be pushed -1 units, and for all y components will be pushed -3 components. So in this case, if this will be represented by x prime and y prime, which is equal to this notation, in general aspect, since we are to generalize the line, because again, there are infinitely many points in the given line, specifically here, and at the same time for our translated line, also true. So what we're going to do here is compare or equate the components, okay, plus v sub 2, and we know that our v sub 1 is actually -1, so you have -1 or plus -1. Similar here, it's -3 because we have here the components of our vector. Let us try to solve, okay, our x and y, so that when we substitute that here, you would come up with an equation L prime containing primes instead of those x and y components as general written. So we can actually write it this manner. This would bring us the idea that our x is actually, or let us not write it there. Let me place it, continue here. So our x here is actually x prime plus 1. As we move 1 on the other side, or as we add 1 on both sides. Similarly here, y is y prime plus 3. With this now, substituting here, instead of 3x minus 4y is equal to 12, as we look for the equation of a line, which is translated line of the given line using vectors -1, -3, we're also going to use the prime. So instead of x, you will have your x prime plus 1, as identified here, minus 4 times y prime plus 3, as identified here, is equal to 12. As you continue, you have 3x prime plus 3 minus 4y prime minus 12 is equal to 12. So you will have here 3x prime minus 4y prime, that's actually minus 9, is equal to 12. So finally, you have 3x prime minus 4y prime is equal to 21. This is the equation of a line, which is the translated line, okay, of our identified line here. So to look into this graph, let's try to identify the x prime and xy x prime and y prime intercepts, or just the x and y intercepts of this. So let's let y prime be equal to 0. So you will have here 3x prime minus 0 is 21. So 3x prime is 21. X prime is equal to 7. Sorry. So our x prime or intercept is actually 7 and 0. For the second, let's x prime be equal to 0. So 0 minus 4y prime is 21. Minus 4y prime is 21. So y prime is 21 or negative 21 fourths. So you have here 0 and minus 21 fourths. Now these two lines are very important because this will allow us to graph the intended output right now. Okay, and our graph will actually be presented here. Take it, it's 7, 0. So 7, so we have 4, 5, 6, 7. Okay, that's part of the translated line. Okay, the translated line. So the next one is negative 21 fourths. That's negative 5 and 1/4. So negative 3, 4, and 5. That's 6, 1/4, somewhere here. So if we're going to connect that, so connect the 2 points. Okay, so it would surely be parallel to the first line. This is actually our line L, indicated by 3x prime minus 4y prime is equal to 21. They are parallel because, as you can see here, the slope for that is, when you're going to identify the slope of your L prime, negative a over b, that's actually negative 3 over negative 4. So the slope is 3/4. Similar to this here, that's also 3/4. So they are actually parallel to one another. So with this now, we have identified that really they are parallel, and at the same time, this being the translated line is actually being pushed similar to our vector that manner. Okay, so you can actually verify that further by picking a point here and identify its translated point and the location of that. If it patterns to that direction there, I'll be leaving that for you. This is how we get the translation of a certain line using a given vector. Thank you very much for watching.